This is my father, Joe Saal, in about 1966. At that time, he was the chief of orthopedic surgery at the Brooklyn Jewish Hospital in New York. And there was nothing he liked more than taking care of patients. He would wake up early in the morning at 5 a.m. to review their charts. He would stay late in the evenings at the office. And he'd go in nights and weekends to deal with emergencies. But then one day, he started having trouble communicating. He lost track of small things like house keys. His speech came out jumbled, and the spark in his eyes began to dim. In the course of a few short years, this once brilliant surgeon who saved people's lives could not even recognize us, his family, his children, his grandchildren, not to say take care of patients. He was diagnosed with Alzheimer's, and the father I knew was no longer here on this earth. His body was here, strangely inhabited by some being who knew me not. Now let me ask you by a show of hands, how many of you know someone or have a family member who suffered from Alzheimer's, dementia, Parkinson's, and on? Yes, almost everyone. Not surprisingly, because each year, millions of people are diagnosed with these terrible neurological diseases of aging. But surprisingly, after decades of failed studies and research that attempts to stop and halt the progression of these diseases, there is hope. After animal studies and human clinical trials which have shown the promise of being able to slow down, even restore health from these diseases, today I'm here to give you a glimpse of a breakthrough. Now, before I do that, we need to spend a little time and understand a bit more of what's in common with these diseases in your body. The human body is an unbelievably wonderful system. Every day, we take in oxygen. The food we eat is converted into the energy that powers our brains, our eyes, our hearts, our muscles. If something gets damaged, a broken bone, a skinned knee, the body quickly repairs and heals the damage. The system is way more amazing and complex than the most wonderful bit of technology to come out of Silicon Valley. Now, how does this happen? Your body is made up of billions, trillions of cells that make this possible. And for today, I want you to think of each of these cells as a tiny city, a well-run, organized city that makes power and energy, builds buildings, repairs roads, collects the waste, and so on. And inside of each of these tiny cities, there's a little factory. And that factory is where the oxygen you breathe and the food you eat is actually converted into energy. And those factories are called mitochondria. Mitochondria are the most incredibly complex systems you can imagine. They're just beautifully designed. They're incredibly efficient. I sort of think of them like maybe the Tesla Model S of the body. But like any great product design, they come along with a few bugs. And the first one is that these incredibly efficient machines process 98% of the oxygen you breathe is converted into energy, 98%. However, the other 2% leaks out and causes what we refer to as oxidative damage or oxidative stress. And oxidative stress is also generated by toxins and pollutants in the environment. It's actually like a fire burning inside your cells. And if this fire burns out of control, it can cause huge damage to your body's precious resources. Now, there's a second bug. While the inside of these tiny little factories is very well designed, the walls of these factories are not made of strong steel, some other material that resists damage. Unfortunately, they're made of a very delicate material, which is sort of like wood. And you might know that wood is probably the last thing you want to have near these fires that are burning. Not a great plan. But actually, the body knows how to take care of that. In this case, we have what are called antioxidants. And the antioxidants are like the water that puts out the fire. And where do we get antioxidants from? They're part of our diet. We eat things like berries, dark leafy vegetables, and those become the antioxidants that fight the fires in our factories with the tiny wooden walls. And after the fires rage, we have to rebuild the walls, so we take in our diet what are called omega-3 and omega-6 fatty acids. We get omega-3 primarily from fish. We get omega-6 from corn oil and other oil products. And those oils end up repairing the membranes of our little factories. So the oil becomes the membrane, and whenever there is damage, it's replaced by what we'll think of as nice, freshly cut wood. And this process of destruction and reconstruction goes on day in and day out. So here's a little model that's showing you what happens in the normal course. The oxidative damage happens, it proceeds, it burns up. You see the number on the bottom is the number of lipid molecules, the oil in your membrane that's destroyed, and it's kept under control by the little green dots. Those are the antioxidants I talked about, which stop the burning fires. So when we're young and when we're healthy, we can keep this very delicate balance between the damage that occurs daily from that 2% of the oxygen that we don't consume and the ability of our bodies to repair it by using new wood. But as we get older, we can no longer keep those two mechanisms in balance. The fires rage, the antioxidants are not sufficient, and in fact, our factories shut down. And if enough factories shut down, the entire city will shut down. And once the city shuts down, poof, that was one of the neurons in your brain that just stopped working. Poof, that was part of your heart muscle which just stopped working. Okay, So what are we going to do? At this point, you're thinking, look, I know how to solve this problem. All we need are more antioxidants to put out the fire. And at the same time, we're going to need more wood, more lipids, to replace the ones that got burned. Unfortunately, it turns out that the membranes of your mitochondria can only take a very small number of antioxidants compared to the amount of lipid or wood they have. In fact, you can only have approximately one, I show here a bucket of water, one antioxidant for every 1,000 lipid molecules. And this is strictly limited. You just cannot get more antioxidants than that in the walls of our tiny wooden factories. So here's what happens in a case of a disease where the amount of oxidation is 10 times the normal, but I have the same maximum amount of antioxidants that can go into our walls. And you see here, massive damage occurs that leads to the death of the mitochondria. Eventually, as we age, we cannot control this process, primarily affects our brains, and one by one, the lights of our cities go out. So at this point, I think I've kind of painted myself in a corner because I've said we need more antioxidants to be able to put the fires out. But I said we can't put more antioxidants into the wooden walls to stop the fires from burning. So what are we going to do? At this point, I have two choices. I can either quickly leave the stage, or I can do an amazing feat, sort of like that other famous Harry Houdini, and find a way to escape from this contradiction. And in fact, that's what we're going to do today. About 10 years ago, I received a phone call from a friend and colleague. His name is Charles Cantor. He is a superstar biochemist. Charles ran the first human genome project. He's a member of the National Academy of Sciences. He has over 400 peer-reviewed papers published. So when Charles calls, I listen. And I can't quote to you exactly the words, but the essence of what he said was, look, we can't get enough antioxidant in the system to put out the fires. But what if we could prevent the fires happening by fireproofing the walls of these little factories? Could we construct an alternate version of those lipids that would not be destroyed by these oxidative fires? And I'm here to tell you that after 10 years of very hard work, we've made that vision a reality. And how does that happen? So I said that the membranes, the walls of our little factories, are made up of these oils that we eat daily. And what we've done is to create a synthetic version of that same oil, but that is fireproof. We actually replace, bit by bit, the wooden walls of that factory with a fireproofed, fortified version of that same exact lipid. It's available in the form of capsules, which you ingest, just like a multivitamin or omega-3 supplement. But the only difference is that it is 50 to 30 times less susceptible to oxidative damage. But otherwise, it's completely safe, metabolized by the body, participates in all the normal functions, except one. It resists being oxidized. So here's that same example that we saw before with the huge amount of oxidative damage, only now 10% of the membrane has been substituted by this fortified version of the lipid. And you can see there's an incredibly smaller amount of damage that occurs. Since then, we've done animal trials and found that mice who are afflicted with an Alzheimer's-like condition are able to still learn and retain memories every bit as well as the normal mice who don't have that condition. In another experiment done with mice that get a form of diabetes, this compound is able to completely protect their retinas, which is one of the tragic side effects often of diabetes, compared to the control mice. And perhaps more amazingly, we have evidence that not only can this approach stop the progression of the disease, but we may be able to reverse the condition. If the tiny factories and little cities are not completely damaged, it is possible for them to regenerate. Last year, we began human clinical trials, and I'm happy to say that the results exceeded our fondest expectation. We saw evidence of reversal of 4 separate measures of the disease progression in these patients. And the results of that will be delivered at a conference later this month, the American Association of Neurology annual conference in Boston, the most prestigious neurology conference in the US. Not only that, but we think that all of these diseases, which involve oxidative damage to mitochondria, may be helped by these compounds. So, had this treatment been available in 1989, my father's career as a doctor might have continued to flourish. His lifespan might have been extended for decades. And he still might have been the father, the husband, the grandfather that we all knew and loved, instead of merely a remnant of himself. We are on the cusp of being able to live not only longer, but better and healthier. And that is my wish for my family, for those I love. And that is my wish for all of you today. Thank you.